Hello and welcome to today's lesson. Today, scholars will apply lines of symmetry to transform figures onto itself. So we're talking about symmetry today. So first, what is symmetry? So consider piece A right here and piece B right here. How many rigid motions, so remember rigid motions are rotation, translation, reflection, would you need to produce this piece from piece A? So let's talk first about how are they related. So look at piece A and piece B. How are they related to each other? Pause this and think about that for a minute. Look at piece A and piece B. Okay. Now the next question asked us, how many rigid motions would you need to produce the image, that's this, from piece A? So let's think about that. Piece A, we can see right here. Looks like this different color. See right here. Well, I can see that same piece. Hold on a second. I can see that same piece right here. So there's 1, 2, 3, 4, 5, 6, 7, 8. So I would need 8 rotations. So I'm actually going to be sort of taking this image and turning it different ways. So the next question asks, can you think of another set of rigid motions that would produce the image if you start with piece A? So I want you to think about that. Is there another set of rigid motions that can produce the same image? So what is symmetry? There are 2 types of symmetry. So there is reflectional symmetry, which is when the 2 halves of a figure are reflections of each other. So you'll see here we could do a line here to show our rotational symmetry, or here. You see all these lines, of reflectional symmetry. So this one all uses reflections. And we also have what's called rotational symmetry. So that's when we're talking about making itself, mapping it onto itself with a rotation that is less than 360 degrees. So you'll notice this figure, every 60 degrees, I would get the same image. And I can find that it's 60 degrees because there are 6 sides, and I know that the entire way around is 360 degrees. So 360, the total number of degrees, divided by the number of sides, which is 6. Okay, so that's how you can always find that. So let's talk about how we identify lines of symmetry. So how many lines of symmetry does a regular hexagon have? So we were just looking at one. How many lines of symmetry does a regular hexagon have? So I can see here, I see 1 line, 2 line, 3 lines through all the vertices. So this one's going through all the vertices. And then I see 3 more lines. And those are going through the middle of the sides. So we add those together to get this image, which gives us our 6 lines of symmetry for a hexagon. Okay, so a hexagon would have 6 lines of symmetry. Okay, so keep that in mind as we go on. A pentagon would have some, but this is how you find them, through the vertices and through the middle of the sides. So now let's talk about how we identify rotational symmetry. So the question here is, for what angle of rotation does the figure map onto itself? So I've got this one, and I'm sort of showing you 3 pictures. You'll notice over here, here's A, B, and C. If I rotate it 120 degrees, that's this down to here. Notice it looks like the exact same picture, except now A is down here, C is over here, and B is up here. And I can rotate it another 120 degrees to get another symmetrical figure. So when we're talking about rotational symmetry, we're going to take 360 and we're going to divide it by the number of sides for our regular polygon. So number of sides for our regular polygon. And that's how you figure out how many degrees it has, the angles for rotational symmetry. Okay, so now let's talk about determining symmetries. So what types of symmetries does each figure have? So let's start with this figure over here on the left. I'm going to make it a little bit bigger. Ooh, there we go. So I'm looking at this and I can see that there is a line of symmetry right here. Ooh, that's a bad drawing, bad copy. So let's go a line of symmetry right here. And I think there's another line of symmetry right here. And another line of symmetry right here. And another line of symmetry. Each time I go from a point to the opposite sort of indent. So that gives me 5 lines of symmetry. So that is for my reflectional symmetry. And then we start thinking about doing rotational symmetry. So I'm just going to erase these real quick. So I start thinking about how far I have to rotate this. So I have basically 5 corners. I got a corner here, 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 and here. So I think every time I rotate so that this corner here moves up to here, I'm going to get another symmetrical thing. So that's my rotational symmetry. So that means that I have 5 points of rotational symmetry. So I'm going to do 360 divided by 5 to find the rotational symmetry. So that's going to give me 70. The rotational symmetry is at 72 degrees. Every 72 degrees, it's going to look the same. Okay? Well, now let's look at the other figure. Does this have rotational symmetry? Let's think about it. Can I turn this? If I turn this, first of all, let's look at the reflectional symmetry first. Sorry. So if I draw a line here and reflect it, it's not going to work because of these. Those make it so those dots are making it so that I don't have a symmetrical figure. So what if instead I try to rotate this? So maybe if I rotate this corner down to here, I think that would work, and that is 180 degrees of rotational symmetry. But there's no other symmetry, it's just that 180. Because this is a rectangle. So rectangles only have one rotational symmetry of 180 degrees. Because they do not have all the same sides. Okay? This is a quick concept summary for you. So you'll notice reflectional symmetry. Figure maps onto itself. When it is reflected over a line, it has reflectional symmetry. Line of symmetry is a line of reflection. So here you see the line of reflection. And then we have a quick synopsis of rotational symmetry. So that's when a figure maps onto itself when it is rotated less than 360 degrees. It has rotational symmetry. A figure with 180 degree rotation has what's called point symmetry. So you see this picture if I took here, if I rotated it 90 degrees, and then another 90, that gives me my 90 degree symmetry. Okay, so go ahead and do your work, and I will see you in class.